Last time, I came up with 5 calendars for Mercury, Venus, Earth, Mars, and Ceres. When humanity colonizes space, we can't just follow Earth's calendar. Each planetoid needs a different calendar for their different characteristics. Let's start with Jupiter. Jupiter has 4 spherical moons, Io, Europa, Ganymede, and Callisto, that are all tidally locked to Jupiter. These moons are very close together. Travel will be quick and easy between them. Because of this, their calendars should be similar. Jupiter's year is 12 years long. This is simply too lengthy. Jupiter's moons should follow a Martian year like Ceres and Mars do. The Jovian moons have day lengths of 1.77 days, 3.55 days, 7.16 days, and 16.69 days. These days are too long. We must divide them into human days. The Ionian day is close to 2 days long, so we should divide the Ionian day by 2 to get a 21-hour, 13-minute, and 47-second day. The rest of the moons should be as close to this as possible. The result is this. These day lengths would fit into a Martian year like this: 776.62 days, 773.79 days, 767.56 days, and 782.1 days. To keep with Mars, this calendar should split into 24 months. These months would be over 32 days long. Since 32 is a multiple of 8, and 3 of the 4 moons have a factor of 8 human days per day, the weeks should be 8 days long. Since all of these day lengths are slightly different, they'll need different length years. The best option is having the last month range from 3 to 5 weeks, or splitting it into 2 3-week months when necessary. This would keep the week synced to the sunrise and sunset of some moons and the months. Overall, a Jovian calendar would look like this. Next is Saturn. Saturn has significantly more spherical moons than Jupiter, 7 to be exact. Here is a chart of their day lengths and human day lengths. We had to cheat a little with Enceladus by having 3 human days every 2 days, but it was necessary to keep the day lengths close together. Based on the number of human days per day, the best week length would be 6 days. This week length would follow the day-night cycles of 6 out of 7 of the moons. Rhea gets the short end of the stick, but with 7 moons to unite, that is expected. The Saturn system should also follow the Martian year. Anything further out than Mars will probably follow Mars to keep a united year length. This table shows the year lengths in human days. With 5-week months and a 24-month year, we get up to 720, just shy of the shortest years. The way to fill in the gap would be to add a week to months when necessary. The most amount of extra weeks necessary would be 10. In conclusion, the Saturnian calendar would look like this. After Saturn is Uranus. Uranus has 5 moons, but unlike Jupiter and Saturn, their day lengths don't line up as well. Here's the table. As you can see, the 2 days to 3 human days cheat is used again. Also, the human day lengths are more varied, the shortest and longest being over 2.5 hours apart. The result of this is that the year lengths are pretty scattered too. The longest year is 100 days longer than the shortest year. For weeks, the best common thread is 10 days. 3 of these weeks can be packed into a month, with an extra week added at the end whenever necessary. After all that, we get the Uranian calendar. Finally is Neptune. Neptune only has one big moon, Triton, so making a calendar for it will be much easier. Triton's day is 5.88 Earth days long. The natural way to split this is into 6 23-hour, 31-minute, and 12-second long days. Since the day-night cycle is 6 human days long, we should make 6-day weeks. To fit these weeks into 24 months, there should normally be 5 weeks per month. This adds up to 720 days, 19 more than the actual year. To counter this, every 6 months should have only 4 weeks, and on leap years, the last month should be set to normal. The result of this is the Neptunian calendar. That's it for part 2. And remember, when colonization actually happens, the calendars will be wildly different. Maybe the moons won't prioritize unitization as much. Who knows?